Alright, we are asked to find the magnetic flux density P at a point. So this is an application of Biot-Savart law to calculate the magnetic flux density at a point away from a current carrying filamentary conductor of finite length AB. So this is the format we are going to be using. This is our formula for calculating this. I is our current flowing. Then alpha 1, to get alpha 1 is this angle here. And how do you get it? You have to connect your field point you are examining to the end of the rod here. Then the angle formed is going to be alpha 1. If you connect this feed point to the other end of the rod, the angle formed here is going to be alpha 2. So let's go into the solution. So I'm withdrawing quickly. So see, I've closed this end, and so now we are going to see that this, after closing here, if we extend this a bit, here is going to be our alpha 1, and this other end is going to be our alpha 2. So we are going to have here as A and here as B. So before we can get alpha 1, if we look for this angle here, let's call it beta. Let's call it beta. If we look for beta, then we can say alpha 1 plus beta equals 180. So if we do that, we can find the value for alpha 1. So let's go in deeply. So look at this. Tan beta is going to be 0.4 over 0.3, and beta is going to give us 53.1. So alpha 1 is going to be 180 minus beta, which is 1 to 6.87 degrees. So tan theta 2, which is this now, because we have a right angle triangle here like this. So this is 0.9 and this is 0.4. So if we look for alpha 2 here, alpha 2 is going, tan of alpha 2 is going to give us 0.4 over 0.9. So alpha 2 should be 23.9. So if we put it into our formula, B is going to give us this. So please, here it is supposed to be times 10 to the power of negative 7. That was omitted. So, which is going to, this is our formula before, this is our formula we are substituting on. So that gave us this. So this is going to be our resulting B. Also times 10 to the power of negative 7. Then this is our final answer, times 10 to the power of negative 7. So see you on the next class.